There's limited acres devoted to sorghum production in the Carolinas and greater southeastern U.S., but I remain convinced that there is a place for this feed grain in many crop rotations. A major reason is sorghum requires less water and can tolerate extreme heat before and during pollination. However, sorghum remains vulnerable to major pests in the region, including anthracnose, grain mold, aphids, and even birds. Efforts are currently underway at Clemson University to increase sorghum's ability to prevent these pests from attacking the crop or to withstand the pressure and still produce high yields. Parent lines with this biotic resistance are nearing release for private companies to license so that they can develop commercial hybrids that are adapted for the Carolinas. Within our research, our first objective was to identify resistance to anthracnose. Next, we wanted to incorporate sugarcane aphid resistance. And third, we added long awns and sorghum in an effort to decrease bird pressure. It was a several step process to evaluate ways to improve sorghum viability in South Carolina. To address our first objective, we implemented a recurrent selection breeding scheme to build up sorghum's resistance to anthracnose. To increase field pressure for effective screening, we planted sorghum behind sorghum in consecutive years to increase the levels of anthracnose. Next, we focused on incorporating a major sugarcane aphid resistance gene called RMES1 into different backgrounds and then selected lines in the field that demonstrated little to no aphid infestation. Third, as we observed in wheat, the presence of awns can deter birds and even deer from feeding on the grain before harvest. Some sorghum lines contain awns, but few are adapted to this location. We're adding awns to elite parental lines and their hybrids to test whether long awns decrease sorghum's risk of yield loss from birds. It is important to note that all of these breeding methods used by the Cereal Grains Breeding and Genetics Program rely on natural genetic variation and result in non-GMO varieties. The Cereal Grains Breeding and Genetic Program is part of the Advanced Plant Technology Program at the PD Research and Education Center. And here our goal is to solve ongoing challenges in crops that are not a major focus by the private industry, like corn, for example, and to create new opportunities for South Carolina growers to take advantage of. We are constantly looking for ways to improve crop yields and farm profit. This breeding program has already had success. We have identified multiple sources of resistance to fungal diseases such as anthracnose, and we have developed adapted lines that are highly tolerant to the sugarcane aphid, and as a result are seeing much less infestation. We are continuing to work on incorporating the long awn trait into existing elite lines to reduce yield loss. I firmly believe that growers need more crop options in the southeastern region and that crop diversification, especially in dryland systems, can improve farm productivity and profitability. Sorghum has a role in our region because of its hardiness, its rotational benefits including decreasing nematode pressure, and its potential use as a feed grain for poultry and swine. Increasing regional feed grain production in grain deficit states in the Southeast, including South Carolina, will increase agricultural sustainability and it will decrease the region's reliance on grain production from other areas.